All right, so let's talk about where we've been. The last lesson that we did out of our packet was 121 and 122. We spent 2 days on this actually. It was the 13th and the 17th. We spent 2 days, and this is where we were taking an equation, turning it into a table, then turning that into a graph, and then we had to describe it. And that's what we talked about when we were going over the assignment, was making sure that you had those x-intercepts, y-intercepts, vertex, that whole list of stuff. Okay, we're done with that. We're moving on. We did not have the 19th on here because that was the day that we did our equation practice. Today we are landing ourselves here. So we're going to do 1.2.3. And we have 2 learning targets for today. One of them you already are familiar with, or you should be. I hope you've seen this. You don't need to write this down, but if I gave you an equation like y equals x plus 2, and I asked you to find me a y value when x is equal to 3, I don't have extra copies, so grab a piece of paper and just write it down there. Y equals x plus 2, and I told you x equals 3. Would you be able to find y for me? You guys had some stuff like this on your assignment. What would y be? If I told you y is x plus 2, and x is equal to 3, what's y going to be? Can you guys do that in your head? It's going to be 5. Are we feeling good about that? Okay, so you guys have already accomplished this learning target. What we're going to do today is we're going to change the way these problems look. Same problem, just a new way to write the notation. Today, and again, don't write this down if you don't want to. You can if you want. Today, I'm not going to say y equals x plus 2. I'm going to say f of x equals x plus 2. And I'm not going to say find y when x is equal to 3. I'm just going to say find f of 3. And the answer is going to be 5. Okay, so you guys already know how to do this. The only thing that I'm switching on you today is we're going to do some different notation. The notation is going to look a little bit different. All right, and it's going to look strange to you at first, and some of you are going to wonder, why do we have to use this instead of this? And I'd be happy to answer that question, but let's go through the lesson first, and then you guys can ask that at the end if you like. So can you guys please find 1.2.3 in your notes? Looks like this has function notation up at the top. Function notation. So as you look down this page, you don't see a lot of y's in this page. And that's because all the y's have been replaced with this thing here, this f parenthesis x. The way we pronounce this is written right here. We pronounce this f of x. So previously, I would have said y equals x squared minus 1, but now we're saying f of x equals x squared minus 1. Same idea, though. Okay. So let's go through this example in part A here. It says find the output for f of x equals x squared minus 1. So we're just using this equation right here when the input is x equals 4. In other words, find f of 4. So this is what the problems are going to look like on your assignments when you're doing this. They're going to give you an equation. They're going to say f of x equals something, and then they're going to say find f of 4. What I need you to understand is that that 4 is an x value. How did we deal with these before when I gave you an equation and told you to put an x value in? Well, we just rewrote the equation. Can you guys rewrite this equation? X squared minus 1. But leave your x's out. Leave a blank space in there. And I'll give you 3 guesses what I'm going to put in this blank space. Anybody want to take a guess? What number am I going to put in there? 4. You got it on the first guess. Nice. We're going to put 4 in there. And then we'll work out what that is and we'll be done. Let's do it. You guys know what 4 squared is? 16, and then there's a minus 1 at the end. 16 minus 1 is 15. That's it. So if I asked you the question, what is f of 4, you all would say 15. All right, let's do another one. I am now asking you the question, what is f of negative 1? Hi. What is f of negative 1? How are we going to do this? Same way we just did. We're still using the same equation, so I'm going to write it down, x squared minus 1, except I left my x's out. What do you suppose we're going to put in place of that x this time? I'll give you 2 guesses this time. What do you think? Someone make a guess. Carly, what are you thinking? Negative 1. You got it on the first guess again. You guys are so good at this. Have you seen this before? You're just naturally talented when it comes to function notation. All right, that's great. Okay, we got to square that negative 1. Remember, when we square a negative, we're going to get a positive answer, always. Negative 1 squared is negative 1 times negative 1, which is 1. And 1 minus 1 is 0. So let me ask you the question again, and I want you to shout out the answer on the count of 3, okay? Here's the question. What is f of negative 1? And your answer is 1, 2, 3, 0. That was awesome. Could do better, but we'll take it. All right, I'm asking you a new question. What is f of 10? On your own right now, could you please figure out what f of 10 is? You're going to follow the same steps that we just did. Use that same equation, rewrite it, leave out the x's, put the right number in there, and then work out what that's equal to. Are you getting this? Yep, good. All right, some folks are still working. A lot of folks seem like you're finished already. What number did you put in there? I'm only giving you one guess this time. 10, good. Do we know what 10 squared is? 10 squared is 100, 100 minus 1. Final answer is, what is f of 10? It's 99. All right, what do you think of this? Does this seem super difficult to you? Does it seem like something you've already done? Just kind of looks a little different, right? All right, part C. I'm going to read this to you. This is pretty wordy. It says, if the output of this function is 24, what is the input? That is, if f of x equals 24, then what is x? And then the last question is there more than one possible input? They're switching things around on us. They're giving us the output, which is the answer. Do you have a question? No? Okay. Then stop. They're giving us the output. The answer to this is 24. So we found the outputs a minute ago. We've got to work our way backwards. So I don't know what the input is. Whatever my answer is going to be what number goes inside of here. But I know that if I took that number and I squared it and I subtracted 1, that my answer would be what? 24. So they're telling us that the answer would be 24. So all I got to do is figure out what number could I square and then subtract 1 and get that answer of 24. That's what will go inside these parentheses. Does anybody have an idea? 5? I'm hearing 5. Is that going to work? Can you guys do a mental check? If I stuck a 5 in here and squared it and then subtract 1, am I going to get 24? I agree. Yeah, 5 squared is 25, minus 1 is 24. So f of 5 will get us where we need to be. So that would be one of our answers. Has anybody found another number that I could also put in here and square it and subtract 1 and also get 24? There is another one. Negative 5? Yeah, because when we square a negative, we always get a positive, right? So if I stuck a negative 5 in here and square it, that would still give me positive 25 minus 1 is 24. So f of negative 5 also works. So there are 2 answers there. Okay, any questions? I'm going to have you guys doing some problems next. I'm going to show you what I would like to see on this sheet when we finish up with this. So for each of these 9 problems, I want you to write down for each of them what this would be, but leaving out the x's. So show me this step right here. So I'm writing down the equation for this thing, but leaving out the x's. And then I want you to show me what are you going to put in for x. In this case, it's -3. And then I want you to tell me what your final answer is and help me out on this first one. What's -2 times -3? +6 plus 4 is 10. So our final answer there is 10. That's the type of work that I want to see. Now, on a couple of these, like f, it's backwards. So when you get to f, I want you to write parentheses something squared minus 1 equals 99. And then this time you're going to have to figure out what that is. And your answer is going to go up here. Okay. So I'm going to give you guys about 5-ish minutes to accomplish this. I'm going to give you a couple little hints. On E, you're going to need 2 blank parentheses because X is in 2 different places. And I will tell you that there are a couple of these that are not possible to do. They're throwing some weird type things that are mathematically impossible. So you will run across a couple of those. Don't be alarmed. All right, we'll come back together in about 5 minutes and discuss. If you finish this, please go on to number 56 and see if you can make sense of how to do this with a graph instead of an equation. All right, get after it. Get my attention if you need a hint, please. So D was kind of a weird one. When you try and take the square root of a negative number, if you put that in your calculator is going to give you an error. It'll say domain error. That means it doesn't like you putting that negative inside of a square root. So that's one of those rules in Algebra 1. We will not take square roots of negative numbers in Algebra 1. We haven't defined that yet. So when that happens, we will just write undefined. When you get to Algebra 2, we'll teach you how to take square roots of negative numbers. It's awesome. Part E was the most, probably the most advanced one because we had to put that 2 into 2 different places in the equation. Should have come up with a final answer of -5. Part F, there were 2 answers. Was anybody able to come up with both 10 and -10? I saw a lot of people had 10. Did you come up with a -10 also? That one was kind of tricky. Part G is not possible because how can you take the absolute value of something and get a negative answer? You can't. Part H was 6. Part I was 2. All right, let's talk about 56. Can I get you guys to go to 56? And can you please, on your graph, highlight this point right here? Draw in this point right here. The reason I did that point is because the question said, what is the output of the function when the input is 2? When they say the input is 2, they're telling us that x is 2. Now, when we're dealing with a graph, we don't have an equation, so we need to be thinking about points on the graph, ordered pairs like this. So this graph is this question is asking me to find a point on my graph that is 2 comma something. Do you see why I highlighted this point right here? What would the coordinates of this point be? 2 comma 0. Coordinates here are 2 comma 0. I highlighted this point because it's the only point on this graph, the only point on that parabola that is 2 comma something. That something is 0. And the fact that that something is 0 tells me that g of 2 is 0. So in part B, when they ask you to find g of 1, g of -1, what they're asking you to find is, can you find a point on this graph that has an x coordinate of -1 And whatever its y-coordinate is, that's going to be your answer here. That's going to be what g of negative 1 is. So look at this graph. Notice that negative 1 is right here. So go up or down on and find a point on your parabola that would have that x-coordinate. Do you see the point I'm looking at? Highlight that point for me. I'm looking at this one. Do you guys agree that this point up here would have an x-coordinate of negative 1? This point has an x-coordinate of negative 1. What's the y-coordinate of that point? What's the y-coordinate? Negative 1 comma 3. So g of negative 1 is 3. I would love for all of you right now to find g of 0 for me. Find a point on your graph that has an x-coordinate of 0. Whatever the y-coordinate of that point is, that would be your answer. So x-coordinate of 0. I think you found me a point with a y-coordinate of 0. I'm looking for an x-coordinate of 0. So we're looking for a point with an x-coordinate of 0. So that would be this point right here. That's the only point on my parabola that has an x-coordinate of 0.
That was the one I was talking about.
0 comma, what's the y-coordinate of that point? 0. Were you looking at this point up here?
No, I was looking at
That one? Okay. Yeah. Do you agree that this has an x-coordinate of 0 and a y-coordinate of 0?
Yeah.
Okay, perfect. Now this last one's kind of different. They're telling us that the output is 1. So this time we're looking for the input, and we know the output's going to be 1. So they're giving us the y-coordinate. We've got to find the x-coordinate. Can you find any points on this graph that have a y-coordinate of positive 1? I see 2 of them. Can you find me 2 points and highlight them on your graph that have y-coordinates at 1? That would be level with that right there. Did you find them? These are the 2 points. I'm highlighting them here in purple. These are the 2 points that I'm hoping you were looking at. These 2 points both have y-coordinates of 1. This one and this one. We just need to find their x-coordinates. And we're going to have to do a little estimating. This one's going to be about 2 point what? Do you think that's 2.5 or a little bit less than 2.5? 2.3. Love it. We'll go 2.3 for that one. And this one's going to be negative what? Negative 0. What do you want to go here? 0.3 again? Negative 0.3. All right. Folks, I'm going to pass out your assignment, and then I want to give you some hints on it before I cut you loose to work for the rest of the period. All right, and number 1, here's the work that I want to see. This is our assignment. You guys can go ahead and start this right now. Y equals 3 plus the third root of x minus 8. So we're going to start all of these problems out like that. We're going to write the equation. We're going to leave out the x just like we did in our work today. And then we're going to put the x value that's in there. Not right now. I will in a minute. Just be patient. What x value are we going to put in there? For this one, we're going to put 16 in there. Okay, I'll leave that for you to finish, but that's the work that I want to see for that. If I'm just seeing answers, when I check this on Wednesday, you might be losing some points on this assignment. 47 is pretty straightforward. 49, you're solving equations. This is like our warm-up from today. If you struggle with the warm-up, you might want to start on this today and ask me some questions today while we have some time in class. I do want to go over 49 part F, which is on the back side. We're going to do this one problem together, and then we will be done. As soon as this thing focuses, we will get after it. Actually, I'm just going to start it. I won't do the whole thing. This problem's a little bit more advanced than the problems that we did in our warm-up, so I want to get started. Could you guys draw me a dashed line going down the page here to help us focus on the 2 sides of the equation? And I want you to focus on your attention on the left-hand side. And before we start adding and subtracting things from both sides, we always want to check for like terms. Like terms are things that have the same variables, or maybe both things don't have a variable. So when you see this 3x, do you see any other like terms for 3x that we can combine it with? Do you see anything else with an x on that side? I do not either. What about this -4? Is there a like term for the -4? There is a like term for the -4. What's my like term for this -4? This 1. I can combine those two things together, and that's going to be my first step for that side. -4 plus 1 is -3. Go ahead and bring down your 3x. That side becomes 3x minus 3. Bring down your equal side. And then look at the other side and do the same thing. Do you see two things that are the same that we can combine together? I hope you're looking at the two things with x's. This 2x, -2x rather, and this 5x. We can put those together because they both have x's. What is -2x plus 5x? 3x. The 5 did not combine with anything, so it just comes down. So first step, combine like terms. All right, from here, this is like one of our warm-up problems. We have x's on both sides. We can't solve with x's on both sides. So we need to get rid of one of these. Would you rather get rid of the 3x or the 3x? 3x, good choice. I'm going to get rid of the 3x. We're doing -3x on both sides. Now this one's going to be a little bit weird, fair warning, because those are going to cancel and these are going to cancel. And now all I have left is -3 equals 5. Now how am I going to get x by itself if there's no x left? The answer is you can't. This is going to be a special type of problem where our answer is going to be a couple of words. Now there are two options. It's either going to be no solution or infinite solutions. It's one of those two. Anybody know which one it is and why? What do you think? Good guess. Why? I'm gonna disagree with you on that part. Well, let me ask you a question. Is -3 equal to 5? Is -3 equal to means the same as in math, right? Now, if we had some x's, I would agree with you, but the x's all went away, right? So if we're just dealing with numbers, is -3 the same as 5? No, this is a true or false statement. This is a false statement. And if it's false, we go no solution. So if it's a false statement, we go no solution. Now, what you said when you told me your answer a minute ago, you said it was infinite solutions. That would be true if, that would be the right answer if it was a true statement, which is kind of what you were saying originally, was that it was true. So if this had said 5 equals 5, then we go infinite solution. Does that make sense? All right. All right, that's it. You guys get after it. Let me know if you got questions.